Hi, my name is Sam Wong. I'm the Vice President and General Manager of TI Battery Management Solutions. Today I'm here with Dr. Chang from University Virginia Tech Center of Power Electronics System. Welcome you, Dr. Chang.
Thank you, Sam. It's a great pleasure and a privilege to be here.
Thank you for your time today to sit with me and chat about energy storage. So I understand a lot of your research is based on power electronics in Virginia Tech. Tell me a bit more about the latest trend you see in the energy storage systems.
Well, energy storage is becoming more and more important topics in the world that we live in. Largely it was driven by the fact that the electrification of the society just accelerated. As we're heading for a more cleaner and sustainable society and more renewable energy gets introduced, they have inherently fluctuation in nature. And also with tremendous growth with the EV and so forth. A lot of those industry growth basically drives for more electricity. Unfortunately, you have to deal with this intermittency. And therefore, there's no other option but to actually go get the right answer for the energy storage.
As you see more and more of these energy storage system need, as an engineer, what kind of design challenges you can see in designing this system to meet the new energy need?
Well, the interesting aspect is, humans are smart. We figured out how to store food. We figured out how to store information. But the fact of the matter is, it actually turns out to be very difficult to store electricity. But nonetheless, we don't have an option. But the good news is there are so many diverse forms of energy storage. The question is, how do you actually turn that into electricity and store it in this really feasible and a cost-effective way?
How do you see, you mentioned a little bit about the electric vehicle and putting the electric vehicle and energy storage system together. How do you see they interact or in a microgrid fashions in the system, in the greater scheme of things?
That's an interesting question, right? So I remember when the EV industry was about to take off, the biggest challenge was the cost of the battery, right? After so many years, I think in the last 10 years, the battery cost has came down significantly. In fact, from one of the data that I read by Bloomberg ENF, the lithium-ion battery costs per kilowatt hour came down about 80% in 8 years. So that's a substantial. But nonetheless, we're still not totally out of the woods yet. We're still looking at continuous reduction of the cost, increase the cycle time, and the safety, and so on and so forth. So the challenge still remains, so there's still a lot of work to do.
But none of that, those are opportunities, right? So from your standpoint, as an expert in power electronics, how do you think the energy storage will evolve with the help of power electronics? What innovation we need to bring to the table, to make this happen?
That's a great question, Sam. I think that is why actually after more than 22 years, I decided to come back to academia, because I think now is extremely exciting time to be at the forefront of the research driven by the challenge like energy storage. And fortunately enough that we are actually, the power electronics tends to be the gatekeeper for a lot of those energy flows nowadays, whether it's energy storage, charging, discharging, dealing with diverse applications like a EV, or put the energy on the grid. So that basically calls for new types of topology, new controls, and new thinking at the system level.
I guess that's great to hear that, and really thank you for your time. I'm really looking forward to industry and also academic partnership to driving this electrification forward.
I look forward to the same, Sam.
Thank you.
Yeah, it's a great pleasure to be here.